Hello everybody, this is a video about poorly designed databases. How can you tell if you have a poorly designed database? Well, it's very easy to recognize. It has a lot of inconsistencies, a lot of data redundancy, and all of this results in three kinds of anomalies or problems, which we'll get to here in a second. Here's an example of a poorly designed database table. It lists several students and the courses that they're registered in. And by the way, there's a little footnote down at the bottom. Forget about semesters and section numbers and things like that. So we've got people who are registered for classes. What I'd like for you to do is pause this video now, take out a sheet of paper, and make a list of all of the inconsistencies and the data redundancy that you see in this table. So pause this video now. Okay, so you got a list made? Let's compare lists. Let's start with inconsistencies. Did you notice that Alice has 3 different phone numbers? What's up with this? There's inconsistencies for Ned. He's got 2 different last names. What is his last name? Sanders or Sanderson? The same thing is true with his student ID. Which of these student IDs is the correct one for Ned? I don't know if you noticed up in the column called course number, we've got 2 K300 classes, one that meets at 8 o'clock and one meets at 9 o'clock. That's very inconsistent. Which is the correct class time here? For redundant data, Alice is registered in 3 classes and her last name is listed 3 times, her first name is listed 3 times, same thing with her phone number. Likewise for Ned, we've got data that's listed over and over and over and repeated in several records. Well, this all results in anomalies or problems. As I said before, one anomaly is an update anomaly. What if Alice had a sex change operation and changed her name to Albert? We'd have to get into all 3 records, 3 different records, and change her first name. The insert anomaly. What if we needed to add a new student before the student had registered for any classes? Well, we couldn't add a student because there would be no related data in the course number and the day and the time column that we could enter. The third kind of anomaly is the delete anomaly. What if we deleted S400? Then we would lose poor Artie Moore since he was the only person that was enrolled in this course. This is much better. If we took this data that we were just looking at and put it into 3 separate tables, we would eliminate all of the inconsistencies and the redundancies and the anomalies. Okay, let's take a look at inconsistent data. We've got 1 record for Alice and it has 1 phone number and everything is consistent there. There's no redundant data. Alice is listed once, Ned is listed once, Artie is listed once. And the 3 anomalies, if we needed to change Alice's name to Albert, we would only do this in 1 location and 1 record. If we needed to add a new student before the student had registered for any classes, that would be easy to do. We could just add the student to the student table. And then the delete anomaly. What if we deleted S400? Well, we would only delete 2 records in the 2 tables on the right, and poor Artie would still be here even though he wasn't registered for any classes, and he wouldn't be registered for S400, and he wouldn't be watching this video.